All right, geometry. Let's go. Where is my, aha, there it is. Okay, we are going to talk about chapter 8, right triangle trigonometry. Let me just get my coffee here. Lukewarm coffee, the best. All right, so not really. So this is about triangles, and that is why we're skipping to chapter 8 because we could go into quadrilaterals, but that would mean more proofs. So I want to take a break from proofs, and I hope you don't mind. So geometric mean is important, but we're going to skip it. Okay, so let's go on. We could do it, but we're going to skip it because the things that geometric mean covers end up in other things. And hey, you have the information, so if you want to learn it, you can read that section and you can ask about it and put in an organizer. But for this video, we're going to start with the Pythagorean theorem and its converse. All right, so I always like to say that the Pythagorean theorem is we know two sides and need a third side. Oop. All right, so what we're going to really focus on here in high school geometry is SOHCAHTOA, where we only know one side, but we know the angles, and we can get two sides. Very exciting. But the Pythagorean theorem, we know the one side, and of course, we did this with the distance formula. I should know the Pythagorean theorem. Okay, so go ahead and pause the video and do those guided practice problems. And if you're not sure about them, you can put those in the organizer. Okay, but all right. Let me just slow down. Let me slow down. When we do the Pythagorean theorem, we're going to start by labeling the sides. Okay, so the side across from the right angle is always your C side, and then the A and B are interchangeable. Okay, so A, B. I'm going to make 17A and 7B, and now I know A squared plus B squared equals C squared. Substitute in 17 squared plus 7 squared equals C squared. And then we just square 17 and square 7. What is the square root of 17? Let's see. 17 times 17. 289. All right. So that's 289 plus 49 equals C squared. And then 289 and 49, 12, 13, 338, 338. And then we square root both sides. And we get C equals the square root of 338. Now, on IXL, they're going to make you simplify your square roots. So you see up here, the square root of 40 is equal to 2 times the square root of 10. What in the world is that about? So let's start with that. The square root of 40 is equal to the square root of 20 times the square root of 2, right? Because 20 times 2 is 40. And then the square root of 20 is equal to the square root of 10 times the square root of 2. Well, hold on, wait a minute. The square root of 2 times the square root of 2, what is that? If we were to go ahead and multiply those together, what would we get? We would get 2. So the square root of 40 is equal to 2, and then the square root of 10 is still there. So that's because the square root of 2 times the square root of 2 equals, by definition, 2. So what about 338? What in the world can we break that down to? The square root of 338. What is 338 divided by 2? 338 divided by 2 is 169. Amazing. 2, the square root of 2 times the square root of 169. Well, guess what? The square root of 169 is none other than 13. So that means that the square root, the final answer here is x equals 13 root 2. Okay? So we could totally work on simplifying radicals because I want you guys to get 90 smart scores. Pythagorean triple, don't forget to put that in your textbook organizer. It's all these special triplet number combinations where it's true that a squared plus b squared equals c squared. There's more than 3, 4, 5. Isn't that cool? 3 squared plus 4 squared equals 5 squared. And so you can use a Pythagorean triple. So notice, oh yes, so that if they're multiples, so 3, 4, 5 is a Pythagorean triple, but if we multiply each one of them by 2, we of course get another Pythagorean triple, the other famous 6, 8, 10. All right, and all Pythagorean triples are sides, could be sides of a right triangle. All right, standardized test practice, no problem. Guided practice, and now we're, oh yes, of course, word problems. So just make sure with a word problem that you draw a picture, label sides, apply Pythagorean theorem. Okay, we'll do those. All right, now the converse of the Pythagorean theorem. So the Pythagorean theorem said that if A, B, and C are sides of a right triangle, then a squared plus b squared equals c squared. Well, the converse says if A, B, and C are sides of a triangle in a squared plus b squared equals c squared, then that triangle is a right triangle. All right. And that, ask a carpenter. All right. Carpenters have this thing called a square. They have an actual tool that looks like this. I think it's called a square. Well, why don't we Google it? Google the thing. Carpenter square. There it is.
According to Wikipedia, the steel square is a tool used in carpentry.
Thank you. Yes, it is. And so what this carpenter tool does is it checks to see if you have a right angle. And it's basically, they don't always know it, but they can do that because of the Pythagorean theorem converse. And look around you, right angles are very important. And also the Pythagorean theorem inequality. So there's all these corollaries because of the Pythagorean theorem. So what does this say? Well, we know that the Pythagorean theorem says a squared plus b squared equals c squared. But what if a squared plus b squared, when you add them together, are greater than c squared or less than c squared? Well, that means something too. If c squared is less, then what do you have? You have an acute triangle. And if c squared is greater, so that c side is so long that when you square it, it's bigger than the other two put together, that's because you have an obtuse triangle. Pythagorean theorem inequalities. And we can use that to classify triangles. All right, so go ahead and try that. All right. Maybe we should do this one here, seeing as it has those square roots. So let's consider this is the longest side because it has the biggest numbers. And so we're going to do 2 root 3 plus 4 root 2. And we're going to say, is it equal? Is it greater? Is it less? What is it then? 3 root 5. So what is 2 root 3 squared? What's that? That is 2 root 3 times 2 root 3. 2 times 2 is 4, and root 3 times root 3 is 3, and this is 12. Everyone got that? So it's 12. And then 4, so then just applying that, that would be 16 times 2, 32. And then 9 times 5 is 45. And then 12 plus 32 is, what is it? 44. Which is less than 45. And so looking back at my theorem is what you should do. Wait, when I added them together, it was less than c squared, which means I have an obtuse triangle. Is c squared the bigger one? C squared is the bigger one. This is obtuse. All right, so that's Pythagorean theorem. But we better not stop there because we can do better. We can do 2 sections. All right. My next class doesn't start for another 20 minutes or so. Oh, special right triangles. You guys are going to like special right triangles. Now, special right triangles are the first triangles where we can know one side and get the other two without trigonometry, without the SOHCAHTOA thing. All right, special right triangles have also caused a lot of people a lot of headache, but not you because you're going to come to class prepared. So there are 2 special right triangles. Please write these down and know them just like everything else. The 45, 45, 90. Okay? You cut a square in half. You know, the square has all sides the same. You cut it in half and then use the Pythagorean theorem. You get x squared plus x squared equals, we'll call that c squared. And then that would be 2x squared equals c squared. Then we square root both sides and we end up with the square root of 2, and then x squared square rooted is just x. And that's where that square root of 2 comes from. So it's something you can memorize, but it has a reason. Okay, and so then if we know, look at this triangle right here. We don't know but one side, but because it's a special right triangle, we know all sides. So the formula for 45, 45, 90, I know I just raced through that, but it's the 2 legs are the same. It's isosceles, and the hypotenuse is that number times the square root of 2. So in this one, I've been given a leg of 4. So I know that the other leg is also 4, and the hypotenuse is not x. It is 4 times the square root of 2. In this one, we have both the legs, so we know 5 root 2. This one, 7 root 2, so we know that the other leg is 7 root 2, and the hypotenuse would be 7 root 2, root 2. And what is root 2, root 2? It's 2. So 7 times 2 is 14. Now, there's another example here because this one here, that one, okay. I'm going to do it, but I also want you to see the pattern. So this is a 45, 45, 90. So we're going to write down the formula. So in this one, they've given us 18 for the hypotenuse. And we know that the hypotenuse, I just said, is x root 2. This I need to copy. So we're going to set up an equation. X root 2 equals 18. Now we're going to solve for x. How do we solve for x? Very good. We divide both sides by root 2. And we get 8 over the square root of 2. In math, we don't leave square roots in the denominator because back in the day, square roots, well, even today, how do you calculate a square root? You use the calculator. And calculators haven't been around except since like 1980. You know, before that, people didn't really use them, and you'll notice we don't use them because. So, in order to approximate square root, what we do, in order to approximate, we just get the square root into the numerator, and then we're always dividing by a whole number. Whole numbers are much easier to divide by. So how do we get the square root into the numerator? What we do is this thing called rationalize. It's very simple. We're just going to multiply the top and bottom by root 2. Because what is root 2 root 2? It's 2, as we've been saying. And what is 8 root 2? Well, we're not actually going to do that. But what we're going to do now is you see the 8 on the top and the 2 on the bottom? It becomes 4, right? 4 root 2. So, did I do that right? Oh, it's 18. I was going to say. So it's 9. Okay, so it's 9 root 2. Now, you don't have to do that process every time. You know, if you did that for every IXL question, it might get a little bothersome. But check it out. 18, 9 is half, right? So this is 5 root 2. Oh, so that's easy, which is 5. But if I had another one like this, let's say 10, and I know this is a 45, 45, 90, then I know that means that the root 2 is on the leg, and the whole number in front of it is half of the hypotenuse. So you may see that. And now we're on to our last special right triangle, the 30, 60, 90. Just a different formula. Okay, so the first formula was for these, the first formula was x root 2, right? Now this one is x root 3 and 2x. I don't know why they're using s's. X, 2x, x root 3. Okay, that is the 30, 60, 90 triangle. And where does this come from? Well, 60 is equilateral, right? You split an equilateral in half and you get a 30 up top. You have the 60 and 90. And equilateral, if you consider that it's 2x, then you just split the bottom in half so you get an x, and then you use the Pythagorean theorem and you figure out that that altitude there is x root 3. You don't have to do that, but you could. What you do have to do is the guided practice. Okay, so here we know where our angles are, and we see that's x. Our hypotenuse is there, and that would be 2x. And that's the x root 3. So we've been given that x root 3 is 12. Wow. Why would they start us out with x root 3 being 12? Because now we have our square root in the denominator again, and we have to rationalize right off the bat. It's not very nice. So 12 root 3 over 3, and that's 4 root 3. So that means that the short leg is 4 root 3 because the short leg is x, and I just solved for x. So just notice that this is the 30, 60, 90 triangle, and 12 divided by 3 is 4. So whereas in the 45, 45, 90, we divided by 2 for that shortcut, here we divided by 3. So if you have the leg and it's like 15, then you know that there's going to be 5 root 3, and then the hypotenuse is double the short leg, so 8 root 3. Let's do some easier ones, and you can come back to that one. We can talk about it in class. Not a good one to start off. Let's do 3b, and you'd be like, oh, that was easy. Okay? In 3b, they gave us the hypotenuse. In the formula, that's the 2x. The short leg is x, and the medium leg has the radical on it. So the long hypotenuse is 10. That's 2x. 2x equals 10. What does x equal? 5. What is the leg? 5 root 3. Okay? In this one, they gave us x. So what is 2x? It's going to be 42. Multiply that number by 2. And then the long leg is 21 root 3. So you'll see 3b and 3c were much easier. And then this is just a word problem. So draw a picture, apply the special right triangles. I think I've said enough to get us started. And then what is our IXL? See, this is another way. I don't need to be making all these Google Classroom posts and reminders, because you could just, you can figure it out by watching this video and listening to me say it here. It's not even figuring it out. It's just watching the Edpuzzle video and paying attention, which is like paying attention in class. So what IXL assignments are we doing? I'll tell you, I think it's R. Let's see. It is, no, it's Q. Okay. We're doing Pythagorean theorem, converse, inequalities. So we're doing Q, 1, 2, 3, and 4. But hey, there's no proofs. So I hope you guys really enjoy it. And then afterwards, we'll be doing R.